Alrighty, class, it's time to begin our lesson for the day. Today we're looking at section 8.7, solving systems of linear equations. And you can find it on this page in your textbook, which actually might be a good idea after the lesson to go and look at the textbook, to look at some of the graphs that they use as examples, because we won't be looking at the graphs right today. We'll be doing that more in class, but it would be a really good idea to look over the graphs on or in this section in your textbook. All right, let's begin. So solving systems of linear equations, which is actually a lot easier than the title might make it sound. But first we have to understand a few things. What is a system of linear equations? Well, I actually know what all these words are, and I think you do too. You know what solving means. You know what linear equations are. Equations that when you graph them, they make lines. Solving means typically that we find the value for like a variable x. Since these are linear equations, there's two variables. So we're probably going to be looking for a what? What is a way that I can represent two variables that I have located or found? Let's see if you remember. And the answer is an ordered pair. That's right. So we're going to be finding ordered pairs on some of these things. And systems, most of us know what systems are. Like you have a gaming system. You're in the solar system. So systems is the word that we use often, but do we really understand what it means? And why do they call it a gaming system? Why do they call it the solar system? What does systems mean? So I'm not going to tell you. You look it up. Find out what this word, systems, really means. And as we go through the lesson, see if you can figure out why they use that word. All right, let's begin. Two or more linear equations form a system of linear equations. Two or more linear equations form a system of linear equations. So, you got to have two or more of these linear equations that we've used already, and they form a system. Okay, that's one definition, and that's the definition you could say for systems of linear equations. So you could underline this word or highlight it or something. Next, a solution of the system is any ordered pair that is a solution for each equation in the system. So a solution for a system of linear equations is going to be any ordered pair that is a solution for each equation in the system. Okay, let's take a look at what that means. First, we're going to take a look at a type of problem that we might be asked. And in this case, we're not actually solving to find the ordered pair. They're actually going to give us an ordered pair, and they're going to ask, is this ordered pair a solution? Now, I don't know if you remember, but there was a way to test, and we did an example like this in class. It wasn't on your quiz, though, but it was a question where, hey, I have an ordered pair here. Let's make this as an example, okay? So this is actually kind of a pre-example. This is just a remember. Kind of a remember thing, review maybe you could call it, but it would give us a problem, and you might want to write a little bit more than I'm writing. I want to write down some of the stuff I'm saying, but it would give us a problem and basically say, hey, you have the ordered pair, or you have the equation y equals 2x plus 3, and it would want to know, hey, is the ordered pair -5, 7 a solution for this? Well, what you do is you plug in the -5 for x, remember, and you find out if 2 times -5 plus 3 would equal 7. So basically, you plug your numbers in and see, do both sides equal each other? If they did, then this ordered pair is a solution for this equation. If it didn't, then it's no. And in this case, it's definitely a no. This is not a solution for that. That's just kind of a reminder. We've already done problems like that. So what we're going to do now is just do it with a system, which isn't very complicated. So for example 1, the question is the given ordered pair a solution for each system? So they're going to give us an ordered pair, they're going to give us a system, and we have to figure out, does that ordered pair fit for it? Let's find out. Okay. So here we have the ordered pair 2, 7, and y equals 5x minus 3, and we have another equation, y equals negative 3 over 2x plus 10. Okay? So let's find out if this is going to work for my thing. And this is important, and you might want to write this down somewhere on here, but is it that you have to test both. You can't just test one, and we'll see. Just make sure you test both, okay? And we'll see exceptions to that as we go along, but just make sure it's a good practice to go ahead and test both. So we're going to plug in. So basically we take this ordered pair and we plug it in to each of these. I'm going to do the first one first. So here I have the ordered pair y equals 5. I'm going to put my parenthesis, and actually I need to go back and erase my y. And so I have parenthesis minus 3. So that's one ordered pair, my one equation. And I plug in my stuff and I have 7 equals 5, 2. So we have this. So we do the math and we see what happens. And I'm going to write my other one over here already. So I have 7 equals negative 3 over 2, parenthesis, 2, close parenthesis, plus 10. Okay? So here we just solve it. And you just simply say, well, I have 7 is equal to 10 minus 3. 7 is equal to 7. Check. That one works. But for this to be a solution for the system, it has to work for both. If it fails on any one, then it's not going to work. It's not going to be a system. The answer is no. So 7 equals, well, 2 times negative 3 halves is negative 3 plus 10. I would get 7 is equal to negative 3 plus 10 is 7. Check. That one works. So our answer for this is going to be yes. Okay, now we come over here. We do the same thing we did before. Write down y equals negative 2. And I need to go back and erase my y. Just get a habit of writing it. So we're going to put our 5 in place for y because the second value is our y value. We put a negative 1 here. And we put the plus 3. And then I'm going to go over a little bit further. And I'm going to put my, my next equation where I would have 5 is equal to x, which is negative 1 minus 4. And if you want, you can use parentheses, but because nothing's actually touching x, it's not as important to put the parentheses. All right, let's begin. So we would have 5 equals, well, negative 2 times negative 1 is positive 2 plus 3. 5 equals 5. Oh, yay, that works. Cha-ching. But remember, we don't get to say yes just because one works. We have to see if this one works. Well, 5 equals negative 1 minus 4. You could do add the opposite, and you would get negative 1 plus negative 4. And either way, if you're able to see without doing that, that's fine. But if you need to put plus negative 4, do that. To see the fact that we end up with negative 5. Whoops, that's a no-go. Doesn't work. Actually, I'm going to put that x, I'm going to put a slash over the equal sign. That does not equal that. So our answer this time around is no. Not a solution. That ordered pair does not work for both of them, so it's not a solution for the system. Okay? It has to work for everybody. Okay? All right, next we have this one. So we have the ordered pair 6, -2, and you'll notice something. This time around, it's not written in y equals form. It doesn't have to be. Now, you don't have to go and change it into y equals form in order to solve this problem, okay? I want you to understand that. Don't go feel like you have to go and solve it in order to fix the whole situation. You don't. Just plug the numbers in, work it out, and you should still have a number equals a number. If those two numbers are equal to each other, then it's a solution for that equation. And we just do the same thing we did above. We work both out to see if the whole system is a solution. So, in layman's terms, just plug them in, do the math. So here we go. I'm going to write it over here. Instead of x, I'm going to put my 6 plus 2, parenthesis, -2 equals 2. So that's my first one right here. And I'm going to write my second one over here. I'm going to put 2x plus, and I put the x again, I forgot. Put the parenthesis and put your 6. Next, over here we're going to put 5. And we're going to, I don't know why I put the parenthesis right there. I'm just going crazy with the parentheses now, forgetting them or putting them where they don't need to be. Equals 2. Okay, so this matches our second one. We've just taken the x out, replaced it with a 6. We've taken the y out, replaced it with a -2. That's what we did. Okay, let's solve these and check. 6 plus -4 equals 2. 6 plus -4, it does indeed equal 2. So 2 equals 2. Over here we would get 12 plus -10 equals 2. 12 plus -10 is 2. And what do you know? So this is a yes right here. So we get a ching, ching, and we say yes. See? Not very difficult. Now let's take a look at the last part. And you need to write these down. I'm going to give you a little bit of a challenge. Let's see. So there's actually a different way to solve these. And we haven't looked at solving really yet. So far we're looking at where they give us an ordered pair and they ask, is it a solution? The problem with that is that often we don't know even good ordered pairs to pick. There's typically, on most of the things that we're going to do, there's only going to be one ordered pair that works for both. Now, at first, that doesn't sound that big a deal, but I mean, think about this. One ordered pair. These are linear equations. They have ordered pairs that go on forever because the lines go on forever. That means that there's an infinite number of ordered pairs for each line. For most of the ones we're going to do, they only have one pair that works for both of them. So what are the chances of us just guessing the ordered pair that fits two random equations? It's not very likely. So here's the thing. One way that you can figure out what ordered pair matches both, fits for both, is by graphing. And I will give you graph paper for these problems in class that I'm about to show you. So you will have graph paper in class for the problems I'm about to show you, and we will go over them in class so that everyone will have those notes. There'll be 4 different graphs we're going to create, okay? But if you want, I'm going to go ahead and show it to you now to see if you want to get your own graph paper and just try to graph these. Now each system needs to be in its own graph. So that means graph 2 equations on one graph. Don't go in graphing all of them on one graph. So I'll show what I mean. Go and graph, for instance, A, you would put on one graph. Graph both lines on one graph. Over here, you would have to graph both on one. And obviously, you can't graph this one until something happens here. Now, I'll remind you in class, but some of you might know already. So here's the challenge. Attempt to graph these 4 systems of equations. Attempt to graph these 4 systems of equations on graph paper. If you don't want to, you don't have to. You're just weak because you're not accepting the challenge. Anyways, so that's the challenge. And you will have to solve some of these to get them in y = form in order to better graph them better. So graph these, and if they're graphed accurately, you should be able to find the solution for all 4 of these. So I want you to write down what you think. If you do this, write down what you believe the solution is and bring it into class, and then we'll discuss and see. If you manage to get this right on your own, awesome, you're doing great. And this lesson might be a breeze for you. So, all right, see you in class. Bye-bye.